Let's continue. As part of Python for data engineering, in this session, we are going to continue Python language fundamentals. In that, let's continue Python identifiers. Let's check in. When we are creating a Python program, when you are writing Python program, inside a Python program, we will take variable name. Let's say program1.py. We will take what? Variable name. First one, variable name. So this name, variable name, it is identifier. Function name, this is one identifier. Class name, this is identifier. So a name inside a Python program is called identifier. It may be variable name, it may be function name, it may be class name. Any name inside a Python program, we call it as identifier. To identify variable, we have a variable name. To identify function, we have a function name. To identify a class, we have a class name. Okay. To identify something in a Python program, we use identifiers. So to define identifiers, we need to follow some rules. First rule is identifier may formed with lowercase a to z, uppercase a to z, 0 to 9, and underscore. Let me take one example to give a clarity on this identifier. So I am taking identifier names, variable name ABC9, underscore ABC9. I am printing a value, ABC9 value, then underscore ABC value. Okay, let me print this one. So let me run this program. So we used only valid lowercase a to z, 0 to 9, underscore for identifier names. Second rule, very, very important rule. Identifier may contain digits, but it cannot start with a digit. You can take identifier with a digit, but it cannot start with a digit. If it start a digit, it gives error, invalid syntax. Identifier may contain digit, but it cannot start with a digit. If it start a digit, then it will give error. So invalid decimal literal. So we cannot take identifiers with the starting of digits. Next, very, very important rule is identifier may start with underscore. There is a special meaning if variable starts with underscore. There is a concept called private. So if you declare any variable with underscore, then we call those variables are private variables in Python. So any Python variable, any Python function, any Python class name can start with underscore. It is valid, but it cannot start with a digit. Okay. Next important rule is Python is case sensitive. Python is case sensitive. Lowercase identifiers and uppercase identifiers are both are different. So Python is pure case sensitive. So lowercase a and uppercase a both are different. Okay. So first I printed uppercase a value because I declared later this one. So you may think if I declare lowercase a, it will override old value with new value, right? Then later I printed lowercase value, it's still printing 200. It means it is not overridden. Both are considered as different variables. Okay. Yeah. Next important one. There is no length limit for identifier name. There is no length limit for identifier name. So I taken a variable. variable name with lengthy name. See here, I taken variable name with lengthy name. I am printing. The problem here is if I miss one character, let's say here I missed one character. Can you guess which character we missed? Let's say I missed one character. Let's see. Sorry. If I try to take this one while printing, if I miss one character, then I am printing, then we cannot know which character we missed. Yes or no? Because of this lengthy name, we cannot identify exact character where we missed that character. So while reusing, we face an issue. That's what it is never recommended to take lengthy names. One, if you miss any character, we cannot find. Second one is, if you take a lengthy names, your entire program, let's say you are using this variable 100 times. Your entire program look like with this variable name. Readability is not good. That's why it is never recommended to take lengthy names. Next, final important rule for identifier is we cannot take any predefined keywords as identifier. If purpose is different, you are trying to take if equal to 20, it gives error saying invalid syntax. If purpose is condition check, but you are trying to take as variable, that's why it is giving error saying invalid syntax. Okay. And next, very important one is Python keyword setting. Every language having reserved words, every reserved word having special purpose, special meaning. It may be Python, it may be Java, it may be .NET. Every language having their own predefined keywords, including our English. In English, he reserved for men, she reserved for women's. It reserved for different purpose. Is reserved for different purpose. Was reserved for different purpose. Every keyword having their own special purpose, their own special meaning. Like that, in Python also, there are some keywords reserved. To know list of keywords, there is a module called keyword. In that module, there is a variable called keyword list. It will give all list of keywords. Okay. So currently, total list of keywords are 35. In that, if you see, except these three keywords, if you see, all keywords are lowercase. All keywords are lowercase. Except these three keywords, all keywords are lowercase. These three keywords are reserved. True and false reserved for Boolean representation. None is reserved for nothing. If any variable do not have value, then we can assign none. If any function not returning any value, we can return none. None means nothing. And false Boolean, true reserved for Boolean representation. Okay, clear writing? Keywords. Now let's start understanding Python data types. So Python data types are very important. So here we are going to discuss introduction, types of Python data types, and different examples. Let's say we are writing a Python program. We are writing Python program. For this Python program, we may get decimal values. We may get decimal values with a fractional part. We may get input as strings. We may get characters as input. We may get Boolean values as input. We may get a different kind of data. For every input, we want to allocate memory, sufficient memory. Then these data types are used to allocate sufficient memory. Second one, to segregate the data. This data is decimal data. This data is decimal with a fractional part. This data is string data. This data is a Boolean data. To segregate data, to reserve sufficient memory, we use data types. We have different types of data types. We have simple data types and we have complex data types. We have simple data types, we have complex data types. Simple data types allows only one value at a time inside a variable. If you try to store different value, it will create another object, it will refer another object, it will release reference of old object. Okay. So using variables, we can hold only one value at a time. One value at a time. We cannot store multiple values in a single variable in simple data types. Coming to collection data types, it can store multiple values in a single variable. It can store multiple values in a single variable. Okay. Simple variable can hold only one value, but collection variable can hold multiple values in a single variable. So now we are going to focus on simple data types, and later we are going to focus on each collection data type very in depth. Each collection data type very in depth. Now let's start understanding simple data types. Simple data types. Okay. Every simple data type is a predefined class in Python. Let me explain other programming languages how we declare variables. In other programming language, first we declare a type. We declare a type, then variable name, value. Okay. It will allocate sufficient memory for that variable. Then later, if you try to change value in that variable, it will remove old value, then it will store new value in same memory. So if I store b equal to 10, it will allocate different memory. If I create c equal to 20, it will allocate different memory. Coming to Python, first I created a variable a, then it will create a memory, and a is pointing to this memory location. Later, after some time, if I change value 20 into variable, it will create a different object with 20. It will remove reference of old object, then it will pointing to new object. After some time, if I store a equal to 10, it will check, is there an object with value 10? Yes. It will pointing to old memory. Then c equal to 20. It will check, is there any object with 20? Yes. C also pointing to same memory. A is pointing same memory. B is pointing same memory. It will save lot of memory compared to other programming. In other programming, B is different memory, A is different memory, C is different memory, even though values are same. But here, it saves memory. Okay. One more important point. Before Python 3.x, there are variable data type called long for storing decimal numbers without a fractional part. So instead of using two variables for decimal data, they removed long data type from Python 3.x. We have only int, int, float, string, boolean, complex data types. And one more important point, in other programming languages, we have to specify the type before a variable. In Python, based on the right side value, data type is going to assign. That's why we call Python is a dynamically typed language. Okay. Let me create a program for all the data types. Okay. Let me take this program. Observe this program too. Observe this program. Okay, first I created a variable a equal to 10. Variable a equal to 10. Then printed a variable and type of variable. Type of function return variable type. So it is printed 10, class is integer. Next, I printed 10.5 and type of 10.5. It is printing 10.5, class is float. Then I created variable C equal to Akkem. Then data type is string data type. And again, I created one variable with value single quote. Strings we can represent either in double quote and single quote. There is no separate character data type in Python. We use either we use only string data type to represent data. Okay, there is no separate data type to say this is character. We have only string data type. Okay, complex data type. Complex data type having two parts. This is real part. This is imaginary part. Complex data type used only in scientific application development, not in all the not in all tell me to not in normal application. Okay, yeah. Next part to now let's understand Python operators too. Very, very important one. As part of Python data engineering, let's start understanding Python language fundamentals. Here, let's understand Python operators. So in this Python operators, we have different Python operators: arithmetic operators, relational operators, logical operators, bitwise operators, assignment operators, special operators. These are different operators. Let's start understanding arithmetic operator. In this arithmetic operators, we have addition, subtraction, multiplication, division, modulo division. Along with this one, we have special separate operator slash slash. We use this one for division operator, slash for division. It will return floating point value, means decimal value with fractional part as a result. But if you use slash slash, it will return only decimal value without fractional part. And this star star become as a power operator. Let me execute. I am entering 10, then I am entering 5. 10 plus 5, 15. 10 minus 5, 10 minus 5, 5. 10 into 5, 50. 10 by 5, 2. But I said slash returns decimal part with fractional part, 2.0. Modulo division operator returns remainder 0. And float division returns integer value. Power operator 10 power 5. This is the value. Okay. Clear, right? Arithmetic operator. Similar to arithmetic operator, we have relational operators. We have greater than, less than, greater than or equal to, less than or equal to. These are different to relational operators. Understand what is the purpose of this relational operators. What is the purpose of relational operator? Relational operators are used to compare two values, relation between two values. Relational operator returns true, both values satisfy condition. If condition not satisfy, it will return Boolean value false. Okay, let me take a relational operator. Let me take the relational operator example. So I'm asking user to enter values. I'm entering 10. I'm entering 5. Then I'm checking 10 greater than 5. Condition is true. 10 greater than or equal to 5. Condition is true. 10 less than 5. False. 10 less than or equal to 5. False. Okay. So relational operator returns Boolean value, either condition true or false. Equality operator. Double equal to, not equal to. This equality operator also returns Boolean value, true or false. Okay. I'm taking conditions for this equality. So here I am passing two conditions to. So 10 equal to 20. Condition is false. 10 equal to 10. Condition is true. 10 not equal to 20. Condition is true. 10 not equal to 10. Condition is false. Equality operator checks relation between two values. If both are equal, it will return true. Both are not equal, it will return true. Otherwise, it will return false. Okay. Yeah. Next one, logical operators. We have three logical operators: AND operator, OR operator, NOT operator. So these operators we can use to combine two conditions, two or more conditions. So instead of conditions, I'm using true, false. Let's say here, AND operator is, I'm using AND operator. So here it will return true and true. AND operator returns both conditions is true, it will return true. Otherwise, it will return false. So except first case, remaining cases it will return false. Okay. OR operator. If at least one condition is true, it will return true. So here for first to three conditions, it will return true. True or true, true, true or false. One condition is true, it will return true. False or true, one condition is true, it will return true. False or false. In this case, it will return false. Except the last case, remaining three cases, it will return true. Next, very, very important operator is not operator. Not reverse of condition type. If condition returns true, it will return false. If condition returns false, it will return true. It will reverse the value. Okay. Not true means false. Not false means true. So these are very, very important operators in Python. Okay. Any questions up to now? No, right? Now let's continue Python collection data types with the different examples. Python collection data types with the different examples. Okay. Python collection allows to hold multiple values in a single variable. Allows to hold multiple values in a single variable. Li equal to these five values we are storing in a single variable. So here we have different collection of data types: tuple, list, set, frozen set, dictionary. These are five important collection data types. First, let's start understanding tuple collection with example. First, let's start understanding tuple collection with examples. Tuple is a Python collection. It holds collection of values in a single variable. Tuple collection we represent using parenthesis. This operator we call it as parenthesis. Tuple can hold homogeneous value, can hold heterogeneous value. Homogeneous means the same type of data. Heterogeneous means different kind of data. It can hold both homogeneous and heterogeneous. Let's start discussing. First, create a tuple to store homogeneous data. I am creating a tuple to hold homogeneous data. Here I am printing entire tuple and I am printing type of tuple. It is printed class tuple. Next one, I am taking a tuple to store heterogeneous data. Tuple to store heterogeneous data. Okay. So see here, I created tuple with different kind of data. I am printing entire tuple. I am printing type of a tuple. Okay, shift enter. You can see I am printing entire tuple. I am printing type of a tuple. Now let's understand important point of tuple. See here, I am printing entire tuple, but my requirement is I want to print value by value. I want to print what? value by value. For that one, we are going to navigate a tuple using index. Here, Python supports both positive index and negative index. It supports both positive index and negative index. Positive index starts from 0, ends with n minus 1, where n is size of tuple. Negative index starts from minus 1, then ends with minus n, ends with minus n. Okay, let's start navigating tuple in forward direction and backward direction. Let's see here. I am navigating a tuple. I am navigating a tuple in both forward direction, backward direction using index. Using index. Okay. Next one too. Next important one. Other way of navigating tuple is slicing operation. Slicing means instead of reading values, we can split a values using, there is an operator called colon operator. So I'm reading first value using forward direction, first value using backward direction, last value using forward direction, last value using backward direction. Here, slicing. I want values from index 1, index 1, index 2, index 2, index 3, index 4, 1 is inclusive, 4 is exclusive. So you will get 20, 30, 40. Okay, let me execute this program. You can see we splitted values, sliced values. This is forward direction. This one is backward direction. I printed total tuple using forward direction, backward direction. 1 minute. So clear, right? How to print values using slicing operator. Next important one is there is a special. Yes, yes. Yeah, sure. Yes, yes. One is inclusive, one is inclusive, four is exclusive. It will print 1 to 4. Here, 1, 2, 3. No, no, no reason. They put a restriction. One is inclusive, four is exclusive. It is in multiple places, not only in tuple, multiple. Yeah. Hmm. Minus 4 is inclusive, minus 1 is exclusive. Second one is exclusive. Until that value, yeah. Next important one is next way of navigating collection. There is a special loop reserved for navigating a collection of values. That loop is for loop. Usually, how we use for loop in other programming languages for initialization logic, then condition logic, condition, we write a condition. Next one is we use condition, then we use increment or decrement logic. Increment or decrement logic in other programming languages. But in Python, you do not require that lengthy logic. You just pass a collection, then in variable in. It will automatically iterate value by value. First, it will take first value, stores in view. We are printing 10. Next, it will iterate automatically second value. It will store into view. We are printing. For loop is specially designed to navigate collection of values. Okay. For loop is specially designed for navigating collection of values. It may be tuple, it may be list, it may be set, it may be frozen set, it may be dictionary, but specially designed for this collection of values to iterate value by value until the end of value in forward direction. Okay. Yeah.